right now. Okay, cool.
So our project is titled Material Solutions to Mitigating the Urban Heat Island Effect, and that is being presented today by me, Gabby, Guarna, and Ellie Miller.
All right, so the research question we wanted to tackle for this project was, how does changing albedo using the mediums of black asphalt versus white acrylic paint versus grassland surfaces affect the surface temperature of the Earth set with pre-industrial CO2 levels at 220 parts per million, current CO2 levels at 400 parts per million, and double the current CO2 levels at 800 parts per million. And in the image on the left, it shows how New York City has painted about 7 million square feet of tar rooftops white to lower temperatures. And the picture on the right shows the Los Angeles Bureau of Street Services having already painted several streets in light gray paint to reduce road top temperatures by as much as 10 degrees Fahrenheit. So for a little bit of an introduction to the issue, the urban heat island effect has been well known since larger cities began to emerge in the 19th century. The urban heat island effect is when metropolitan areas are a lot warmer than the urban areas surrounding them. Heat islands can affect communities by increasing summertime peak energy demand, air conditioning costs, air pollution and greenhouse gas emissions, heat-related illness and mortality, and water pollution. The materials that have become popular in modern architecture and road construction reflect much less solar radiation and absorb more than the vegetation they have replaced. Some of that absorbed heat is re-radiated, warming the surrounding air. So that means the darker the surface, the more heat capacity it has. And for some comparison, fresh asphalt reflects only 4% of sunlight, compared to as much as 25% for natural grasslands and up to 90% for white surfaces, such as fresh snow or white paint. This is something to keep a close eye on as we continue to urbanize and warm the planet, because these global temperature increases may eventually create a positive feedback loop and amplify the urban heat island effect. We also wanted to determine if the renaturalization of urban regions would prove to be more impactful than painting the pavement and building lighter colored structures in urban regions. Our goal in this project is to examine the change in Earth's surface temperature by varying the material and effective albedo to understand how continued urbanization will impact our global climate system and develop material solutions to lessen the far-reaching impacts of the urban heat island effect.
Okay, so I'm going to talk a little bit about the methods we used to answer our question. So first we used UChicago's RRTM model, which as we know models the radiation coming in and out of the Earth. We used RRTM because that let us change certain parameters that would allow us to collect data on albedo's effect on surface temperature. So we manipulated 3 different variables: CO2 concentrations, which as Ellie mentioned before were pre-industrial levels, current CO2 levels at 400 parts per million, and doubled CO2 levels at 800 parts per million. And the other 2 variables we manipulated were albedo and surface temperature. We tested 3 different albedos: asphalt, white acrylic paint, and grasslands. The reason we chose these albedos was because we wanted to investigate the urban heat island effect under different carbon dioxide conditions. And asphalt is the most common surface used for roadways in cities, which is what contributes a lot to the heat island effect. We chose the other 2 albedos to see what would happen if we either painted all the asphalt white so that it would be more reflective, or if we put grasslands instead. We know that cities probably will not change their streets to grasslands, but as many cities are looking into more green spaces or green roofs, we thought this might be something interesting to compare with the other 2 albedos. So for each albedo, we tested each carbon dioxide level. And as you guys know from our last labs, the output of RTM is the difference in incoming and outgoing radiation. So since we wanted to find difference in surface temperatures, we had to plug in different values for surface temperatures, for the surface temperature for each parameter change, to make it so that the energy coming in was equal to the energy going out. This meant that the temperature we plugged in represented a balanced energy system and would be what the average surface temperature would be under those specific circumstances. So we then took those temperatures and graphed them into these plots, as you can see. So what we noticed was a general upward linear trend. So as the carbon dioxide levels increased, the temperature increased as well for each surface type, which is what we expected. Something interesting to note is that the slope increases for asphalt around 400 parts per million, whereas it decreases for the other two. This is because it has an overall heating effect, so it absorbs more heat than the other two, resulting in a more rapid heating. Our results also showed drastic differences between the different albedos. So as you can see, asphalt had a maximum temperature of 329 degrees Kelvin. White paint had a max temperature of 287 degrees Kelvin, and grasslands had a max of 294 degrees Kelvin. This was in line with our predictions that asphalt would result in the highest temperatures and white acrylic paint would have the lowest temperatures, with grasslands somewhere in the middle. Just as a reminder for comparison, the current surface temperature today is about 288 degrees Kelvin. So the asphalt will make the earth much hotter than if there were another surface type used, such as what we mentioned, like acrylic paint or grasslands. The temperature might not be quite as hot as the model suggests, but we will talk more about that later. However, despite this, we can still see that white paint and grasslands are a far better option.
Right, so in conclusion, we found that the use of white acrylic paint significantly decreased overall surface temperature when compared to traditional black asphalt and grassland surfaces, and has a very promising potential of mitigating the urban heat island effects in real life. As Gabby stated earlier, white acrylic paint surfaces yielded the lowest temperatures, ranging from about 283 to 287 degrees Kelvin, which is about 50 to 57 degrees Fahrenheit. The grassland scenario came second, and then black asphalt albedo yielded temperatures from about 324 to 330 degrees Kelvin, which is about 123 to 134 degrees Fahrenheit. When we were initially looking at this data, we weren't surprised when we got these low temperatures for the white acrylic paint, as it has the same albedo of ice, which is 0.8. That helps explain the large temperature differences between these two surfaces. That being said, we feel that it's important to note that the surface temperatures provided by the RRTM model are not entirely realistic, as the model averages albedo values across the entire globe. So although we can never paint the entire surface of the Earth white, we still feel that this is a worthwhile thought exercise in analyzing what effects white acrylic paint could have in decreasing the amount of heat produced in urban centers across the globe. And we were also able to find some literature that relates to what we investigated today. Professionals like Keith Olson of the National Center for Atmospheric Research in Colorado found that if every stretch of urban pavement were painted white, it would delay warming by 11 years. In addition to that, there are far-reaching, very real-life benefits that come with decreasing the surface temperature in urban areas. Preventative actions like painting streets white could drastically increase the quality of life for those who don't have the means to do it themselves by decreasing air condition usage, driving down energy costs for individuals, and bolstering overall public health. Especially today, taking action to mitigate the urban heat island effect is an important proactive step that all cities should be taking to protect people and their quality of life, especially as cities throughout the globe continue to see record high weather patterns due to climate change. And we found that there are a few cities who have proven that these solutions can be implemented. In 2018, the city of Los Angeles painted some of their streets white, and today those streets are now 10 to 15 degrees cooler than their traditional black asphalt streets. So from our discussions today, we can see that there is a lot of promise on this front of taking action to cool our urban areas by painting streets white with acrylic paint.
All right, and some questions we had for further investigation. Our first one was, what is the cost projection for the naturalization of urban spaces or converting to the use of white acrylic paint globally? And also with that question, it's important to determine which option would be favored from a public perspective, since this is taking place in highly populated urban spaces. And our second question is, what is the cost-benefit analysis of greening cities, and is this a viable market to pursue in order to mitigate the impacts of the urban heat island effect? Because we think of green roofs and the implementation of greenery into architecture, thinking about how much of a dent they would make on the urban heat island effect. And most often greenery is for frill and decorative purposes. not truly to tackle climatic issues such as the urban heat island effect. So that would be something to consider moving forward in this investigation.
And so the last question we'd want to investigate further is, what effect would the greening of urban centers have on low-income urban communities, and would the benefits outweigh the possible costs? In the past, the creation of green spaces in urban centers has furthered the exclusion and displacement of many residents. And so although environmental improvements in cities like New York and Los Angeles generally increase the quality of life, they also increase property value, which prices out vulnerable residents from their home communities and creates a phenomenon known as green gentrification.
So that's all we have. these are our works cited, and we hope that our presentation has provoked some interesting ideas and thoughts. Thank you.
Thank you.